Hi, um, I'm Paul Kaplan. I'm a software engineer with the Scratch Foundation. Been with Scratch for around 4 years, and we will be doing a presentation today about Scratch Lab and about specifically face sensing and the kind of ethical implications of that. And it will be interactive. You'll get a chance to experiment with some of these prototypes and just engage with the questions around face sensing and ethics. I want to give the other two a chance to introduce themselves. So Kathy, do you want to introduce yourself?
Yeah, sure. Hey everyone, glad to be here. My name is Kathy Wu, and I'm a designer on the Scratch team. And I was working on some of the research with machine learning on this project, and I normally work on designing for the community and brand of Scratch. And I'll pass it on to Eric.
Hi, folks. I'm very excited to be here. I'm Eric Rosenbaum. Been involved with Scratch for many years. I'm a member of the engineering team and project lead for Scratch Lab. Yeah.
Great. I hope Scratch is familiar to everybody, but if not, a massive online community for creative coding, a platform for kids to explore coding in a kind of creative way through making art and games. And it shares the same lineage as the Clubhouse network itself, slightly later, from the same research group at the MIT Media Lab. And until last year, we were all housed ourselves at MIT, but we're now, the Scratch Foundation is now its own nonprofit. And last year, we introduced Scratch Lab as an effort to explore new areas of coding and creative learning, and to commit to, and it's our kind of commitment to innovation and exploration, to acknowledge that the raw materials of computing have changed, and we want ways to continue to explore both like what's nearby to kids and to young people in the computer space, and how we can kind of align our creative learning efforts more closely with what's kind of in the air for kids. So today we are going to demo and try out one of Scratch Lab's projects, which is Scratch Lab itself is a kind of customized version of Scratch that has one new extension. So it provides new kinds of blocks to use. And roughly, we'll give an intro to the face sensing extension, do some demo and playtime, and come back together to discuss both, what's fun, what's working, what's not working, and how we can use face sensing as a tool for engaging kids, both in the creative play aspects of what face sensing affords, but also the ethical considerations and safety considerations around machine learning. So with that, I will give this over to Kathy, and Kathy, I can keep going on the slides.
Yeah, that sounds great. Cool, I'll let you know when to switch. So I'm going to share a little bit about what face sensing is, and we can't really talk about face sensing without also mentioning machine learning. And machine learning is this kind of broad umbrella of technology that I'm sure many of us have heard of at some level. But what really is it? It's a pretty complex and opaque technology. You hear it in the same conversations of artificial intelligence because it is a kind of AI technology. As you can see, Eric is demoing something that you can do with this particular technology. So in this slide, what's going on? So on the left is a person from Google demoing one of Google's machine learning models that's picking up different points of the body and able to track where it is in space. And on the right is me as Kermit with the Kermit filter on my face, and is able to detect when I'm opening and closing my mouth. And what machine learning also is, a complex technology summed up in a simpler way, is you have lots and lots and lots of data that you're feeding into this model or program, and you're training it until it gets better and better at recognizing specific patterns and giving them back with accuracy. So that's what's happening on the left in the demo. It's also because it's a pretty complex and expensive technology to develop, even though it's something that we see a lot in our daily lives, it's something that, you know, small researchers and teams at large companies and at research labs have access to actually shape. So on the next slide, we have a video from a computer scientist, researcher, advocate, and founder of the Algorithmic Justice League, Joy Buolamwini of MIT Media Lab. And she's a really strong advocate and voice in the space, talking about what happens when you have really limited set of training data and also not particularly diverse teams who are creating this technology. So we'll just play like the first few seconds, and Paul, let you know when to stop. But this is part of
a confession. Sometimes, with no one in sight, I code in a white mask. As I make whimsical systems to paint walls with our smiles or project inspirations on faces, I enjoy using code to make my ideas a reality. Computer vision powers my creations, making it possible for machines to detect faces. But at times, I'm invisible. You see, machines view the world through a coded gaze. They digest pixels from a camera in dictated ways. Using machine learning, we create training sets with examples that help the machines detect new faces. A lack of diversity in these training sets leads to limited systems that can struggle with faces like mine. To save time, code libraries for facial recognition are shared like off-the-shelf parts. Many computer vision projects.
Paul, can we pause the video? Okay, awesome, thank you. So this is part of like a trailer set of videos that she's released. There's actually a documentary that just was released on Netflix yesterday called The Coded Gaze that would highly recommend checking out, that explains more of this in detail. We will include this video and some other resources in a handout at the end of today. But yeah, she's highlighting this issue and this term algorithmic bias. And for us, like it's crucial. It's crucial that these things are working well for everyone and that they're fair. So on the next slide, there's just a few examples that highlight how pervasive this technology already is, right? It's not particularly accessible to develop, and it's rather opaque. You could say it's quite black box. And at the same time, we're seeing this like everywhere and interacting with it almost every day, right? And young people especially are encountering this in apps like Snap, Snapchat, Messenger, Instagram, TikTok. On the left, there is me with the glasses on my face. And you probably have all seen, some of you have seen the viral video of that lawyer who is wearing a cat filter on his face. So what can we do that this technology, there's so many critical questions that we want to ask of it, and at the same time, it's so ubiquitous. So for our team, we were asking, how do we introduce these questions and these challenges in a safe way that encourages kids to be creative with it, not just receiving what software companies are providing, but also being able to engage in it ourselves and in a way that encourages critical thinking. So on the next slide. So in our process of developing face sensing, which you'll get to interact with very shortly, we were centering these 5 principles. The first one is safety. Whenever there's something for young people to try that involves the webcam, that's definitely very front and center, safety and privacy. So with Scratch Lab, already it's kind of this like walled garden space that's separate from the community. But on top of that, the technology itself, it's never storing any of your data from the webcam, and it's never sending your data anywhere. So it's only just happening within your own browser for that experience, nothing stored or sent. For the underlying model that we were going to use, the machine learning model, that's like the base technology for it, we were only going to proceed with using it if we felt that the model had sufficient published data and tests that they had done on different images of people from different races and genders, that it had performed pretty equally well across everybody. And then finally, for responsibility, transparency, accountability, we have been in conversation with AI ethics and experts in the field and thinking about, if we're going to proceed with this technology, we want to have a conversation with our broader community, which includes you all. And on the point of accountability, taking in feedback that we get to make things better and make sure we're headed in the right direction. So on the next slide, you'll just see an image of a blog post that we published a couple of months ago, which you can read if you want more in-depth dive of our process and how we're thinking about this. And on the next slide, all that given, we are really excited for kids to be able to ask these questions of this technology and in a way that centers their own experiences and creativity. So before, maybe you're only able to use this subset of face filters that Snap already gives you. But what if you could make a game with your own face or extend the uses of this technology to other things? Or what if you could make a new kind of project? In the middle example, you can see someone is playing with a assistive UI for someone with limited mobility to be able to use the technology to speak on their behalf. And on the left-hand side, you have an image of the camera being fooled, so the machine learning technology being fooled. So we want to encourage that too, for people to express and tinker with the edges of this system and try to trick it and see, not just endorsing this technology, what it can do, but also seeing ways that we can trick it or be mischievous. So I'll pass it off to Eric, and he's going to take us into some demos.
Cool. Yeah. So as you can see, I'm wearing a face filter provided by Zoom. It's the same type of technology. I'm going to turn that off though, actually. So I'm no longer a bear. There we go. And instead I will share my screen. So, so that I can give a quick demo before we go to hands-on. Feel free to ask questions in the chat. So hopefully you're seeing now the ScratchLab face sensing site. I'm just going to click try it out. And when that loads up, you're seeing a version of the Scratch editor. So if you haven't played with Scratch before, on the left-hand side, there are these blocks. So the face sensing blocks are these green ones. To run the blocks, you just click on them. That's one way to try them. So this, I'll zoom in. So this one says go to nose. We're programming the cat right now. I can click on it and it will go to my nose each time I click. So the face sensing technology knows where my face is and I can make use of it. This forever block will make that go to nose block run over and over again. So when I click on that to run it, now the cat is kind of stuck to my face. Suppose I didn't want a cat. I don't know what I want. I'll get a surprise sprite. Now I have, oh weird, I have a grasshopper stuck to my face. Or I could paint my own drawing and attach that to my face. Oh, attach that to my face. Huh, that's cool. I've got a purple thing on my face. So now you can maybe start to see a little bit of how it's like those face filters, but where you can make your own and program it yourself. So I'll just show you if you go back. So I clicked at the top left there to go back to the home screen. If I scroll down, there's a few things to try. Forever go to nose, like you saw, or when a face is detected, play ta-da. And then if we scroll down a little further, there are these starter projects. So let's load one of those up. So there's just a tiny bit more code here. It's not doing anything yet. I have to click the green flag to start it. And now you can see I've got kind of like a costume. I can also click on the hat to change to different hats. I'm a bear again, that's good. Different glasses, so that's fun. If we go back here, there's this, another example is called Flapping Bird. So if I click the green flag to start that one, now the bird is just going to the top of my head. And so I can kind of fly it around while it animates to try to collect the strawberries. Cool. So you can make face sensing games. And the third example is this soundboard. So this is the assistive technology example that Kathy mentioned. And it just, each of these, they're called sprites. This one that says hello, we're looking at its code. When my mouth touches it,
hello,
it speaks.
thanks,
And you could say
yes, no,
different words with each sprite, or play different sound effects or even music. Okay, so that's the quick demo. I'll pause there to see if there are any questions before moving to the next part. Oh, but I can't see the chat right now.
I'll let you know if there's something in the chat, Eric. So far,
Okay.
not yet.
All's quiet. Okay, I'm going to put back the hat and glasses on. Actually, maybe Kathy, you could, if you don't mind, share that handout link and just a direct link on the chat so people can get started trying things out while we're talking here.
Yep.
But what I want to share is this prompt of finding the edges. So what this thing does, it's following my face around, changing size, tilting. It's pretty amazing, but it's not magic. It's just face sensing technology. And so you can fool it. So for example, if I cover part of my face, it starts to get a little glitchy and maybe even put the costume in the wrong spot. But actually it's remarkably good at still finding my face even when it's partly covered. I happen to have a mask here. If I put that on, amazingly, it still knows, it can see enough of my face to work. If I cover my eyes, now I can't see anything, so I don't know if it's working. You'll have to let me know whether or not that worked. I don't know. It can also recognize other kinds of faces. So this, if I get myself out of the frame here, I can try this, a Lego person. When they're far away, it's too small, but if I get close enough for it to be able to see, suddenly it is detected as a face, but not when it's upside down. I also have this little baby hedgehog. Oh, it thinks different body parts are face parts. Baby hedgehog doesn't even have a normal kind of mouth, but it still sort of works. You can also use photos of people. So here's, I haven't tried this one before, but this is an embarrassing photo of myself as a child. And there we go. Amazing. So you can just load up a picture on your phone and hold it up to the camera. And perhaps most amazingly, even just a quickly sketched drawing of a face can also be made to work. But what features does it need for it to work? So you can experiment with different kinds of drawings to see what does and doesn't work. I'll pause, I'll stop there. Okay, folks. So Kathy has shared a link to a document with an overview and a bunch of different links to investigate. And then also there's a link directly to lab.scratch.mit.edu/face. I will suggest when you try this, that we found it works best if you turn off your own camera on Zoom when you are using the camera on Scratch Lab. It does work in some situations, but if you're having trouble, that's one thing that can help. So now we're going to move to free play time. Feel free to chime in with questions. We'd love to hear your thoughts and ideas as you poke around and try things. And then we'll gather back together for discussion in about 20 minutes. Paul, Kathy, anything to add?
Yeah, and just let us know if there's any questions you come along the way. We'll be here.
So yeah, please give it a try. We're excited to see what happens. Oh, I see a question in the chat. Do users have the capability to access the back end of the face sensing feature, or is that obscured due to safety or other concerns? What might be meant by the back end of the face sensing feature and accessing it?
Hey, I can chime in. That was my question. I was thinking, I know with a lot of the block programming at different applications, sometimes you can go in and see some of the backend code, either Python or, whatever that is. So I was curious if there is access to kind of the more raw code for that feature, or is it blocked because of the concerns you guys were discussing earlier about, the safety of all of these kinds of features?
Oh yeah, great question. So generally speaking, the design of Scratch, perhaps unlike some other platforms, is that it's sort of all one thing. There aren't multiple layers to open up. So we don't provide access from the face sensing blocks to the code underneath them. But the reason is not the safety or privacy or other ethical concerns that Kathy was talking about, because we do believe that the underlying system that we used, which is provided by Google's TensorFlow project, it's called BlazeFace, that system is sufficiently fair, safe, and private to be used in this way. It's more just like a design decision that we feel like what we put into the blocks is sufficiently accessible, but also flexible for people to make a wide variety of projects.
Cool, we got a gotcha, thanks in the chat. We'll also say that given Scratch Lab is sort of this experimental space, this extension will not work if you have like a tablet. So if you happen to have a computer, then it's best to use that. And otherwise, if that doesn't work for you, let us know and maybe we can find a way for you to still experience it. Any other questions from folks?
Yeah, how's it going?
What does set size to face mean? It comes as big as your face?
Yeah, so like if you open up the hat and glasses version, that uses a stack of 3 blocks, one that positions, say, the hat on your head, one that rotates it to tilt in your head direction, and one that sets it to the face size. So the face size is kind of an estimate of how big your face is on the screen as you move front and back. And then there's a property of sprites, which is their size. And so it just sets the sprite size to the face size. And the usefulness of it is that it becomes a little bit 3D. As you get closer, the sprite can get bigger, so it can appear to actually be attached to you.
Thank you.
Mm-hmm. Another way, just one other thing to investigate is there's a block a little lower down that says face size. It's actually the last block in the category. It has a little box to the left of it. If you check that box, there's a number. So that's actually the estimated face size. And so you can see it changing as you move your face forward and back.
Hey, it's Alexis again from Gold Crown. I know you mentioned a little bit about TensorFlow, which I know is a really cool library, but I was wondering if you could talk a little bit more about your development process of this tool. I'd love to hear some of how your work kind of led up to this.
Yeah, I've been talking a lot, so if either of the other two want to jump in.
Yeah, I had to switch my headphones, so just want to make sure I'm coming through okay. Yeah.
Sounds good.
Good. We've been working on Scratch for several years. It's gone through a couple of different iterations over time. Back in 2019, 18, we released the Scratch 3, which was kind of the newest version of Scratch. That was rebuilt after Flash went away, and we wanted to keep this kind of like exciting programming environment available on the web browser. And we have over time experimented with a lot of different kinds of extensions to Scratch. Scratch itself is a really big online community, and so there's kind of a high bar for introducing new features to Scratch, because they're features that will go out to everybody in the community. And so they not only have to be sufficiently fun and exciting and generative creatively, but they also have to work on a wide variety of machines. And there's a number of kind of barriers there. And so ScratchLab itself was kind of okay, so if we're gonna if we're going to isolate, like without thinking about having to deploy something to an entire worldwide community, maybe are there places that we can kind of experiment if we're just talking about something that won't necessarily be shared out to the entire community or have to work on every possible machine. And we've, over the last couple of years, gone through a couple of different versions of this type of face sensing extension. And the iterations that we've gone through recently have focused a lot on the actual data source of the model. And so I'm not sure, Eric or Kathy, if you want to talk about the kind of data provenance issues with choosing a machine learning model.
Yeah, I can touch on that briefly. Eric was behind kind of rigging that up on the development side, and we were researching various different models and looking at some that was just the face, and some that were like more full body, some that could include multiple faces. And we picked this one ultimately because it had the best published documentation on like all these kind of complex internal quantitative tests that Google had done on different people from different geographic parts of the world. And for us, we're like, okay, well, let's also just like do a few like internal, like more informal tests. And so once we were comfortable with that, we were kind of trying it out within our own team. And in terms of the kind of like design or like the broader like playfulness question, we would do what we call like play tests or workshops within our own team, and then also do them with young people who we, were either partners with that school or just had some relationship with them, and we get some feedback from them too. They'd be like, oh, this is like working well, this is like not working as well. And that informed, I can speak a little on the design perspective, the design of the blocks and like the language that we used. Before we have the version you see now, there was one block that was just called attach to face, that just like did all the magic for you under the hood of just having a sprite just stick and follow your face around. But we're like, well, maybe we want to like break that out a little bit more. We still want it to be really easy to get started. But what if you like wanted something to stick your face, but not like change size? That block was really magical. It was also making more assumptions on like what a person might want to do with it. So that was one of the decisions that we made in that process.
Yeah.
Cool. Yeah, thank you for asking. Cool. I was thinking, feel free to still keep asking questions, folks, or sharing anything that you are discovering and playing with this. I'm just going to play a little bit of like music while we're working too.
Oh, cool. Thanks, Ken. Oh, do you have the ability to share computer sound?
You hear that?
Stevie Wonder.
Stevie Wonder.
Switch back over to a discussion mode. I'd love to see people's faces if that's possible.
Yeah, can we get some like thumbs up if people are ready to move on? Or cameras on is great, even better.
Oh, and also if people want to try sharing what they've been experimenting with, we'd love to see that as well. So you can try screen sharing and see if it works for you. So any volunteers to just show us what they've been poking at, any discoveries that they made. We don't expect finished projects in such a short time, but if you do feel like sharing, we'd love to see. And of course, any more questions or ideas that you have, we'd love to hear.
Cool. I'm going to turn off the Stevie Wonder.
Always love to have some Stevie Wonder.
Well, hi, I'm Brian from Argentina. You can't see me because I'm using the webcam at the Scratch page, so it seems that it chooses to be, my face chooses to be there. I'm not here, but first of all, I wanna thank you and congratulate you all the work that you do at Scratch. It's amazing, and this feature it's amazing. I love it. What I've done, I don't know if let me share the screen.
Oh, all right.
Yeah, it's very easy. 1 second.
It's a good song.
Can you see my screen?
Oh, yeah, it's working.
Yes, that's perfect.
I'm covering my camera because I don't want the Scratch to watch me, to see me yet. This is it. It's very simple. If you know coding, you see what it does. It's very simple.
I am beautiful. What they say.
I think I thought about working with kids and teenagers, and it's very useful for working in self-confidence. You know, every time you show up here, says you're beautiful. So let me show you again.
I am beautiful, no matter what they say.
It's very, very, very simple, but I'm sure that if you have this program or this this game, this program every day in your life, your self-confidence will rise. So yeah, now that's it. It's very simple. Thank you again.
That is a wonderful idea. Thank you so much for sharing that.
Yeah, thank you so much. We're getting a few clap emojis in the group too. That's lovely.
I love the simplicity and power of the idea.
I can share.
Oh, thank you.
Yeah, I was struggling, I'm not gonna lie. This is not my gift, but I can we'll see how this works. Share my screen. Is this camera not working?
Oh,
it's working. I see you.
Oh, do you? I don't.
Yeah.
Okay, great.
Looks great.
Yeah, I think like the biggest thing is like these puzzle pieces. It's nice that they're puzzle pieces, and I'm sure as you use it, you'll learn this more. But so goes to the top of my head.
Hey.
I tried to watch the video that you directed with Eric, so now I can move it with my face.
nice.
Oh, that's awesome.
Yep, that's it.
Awesome. Thank you for sharing. It's
Yeah,
fun. It doesn't always get a lot of spotlight, so glad to see him get some love. Seeing some hearts in the emoji reacts too. So
You know how I stop sharing? Am I still sharing?
Oh, yeah. Oh, you got it.
Yep.
anyone else have something they want to share or some observation they had?
Oh, I saw a comment from Justin, working on inverting my video feed to Chrome to see if it recognizes me. That's, yeah, like using a kind of hacking the system to make a virtual camera and seeing if Chrome will pick that up. It seems possible. You could easily make it not work that way. It didn't like it. Okay, good to know. Thanks. I'm not surprised. Yeah, but that's an interesting experiment.
I can share mine.
Cool. one of our early dreams or brainstorms too, like what if you could do things to like play with the camera within Scratch, or like change the like darkness or lightness of the image or the contrast. There's definitely things you can do kind of in the analog world too, with lighting and, you know, physical filters on your cameras to see how much you can push it. Appreciate the tinkering.
Totally, tinkering with the camera. Jonathan was going to share, I think. Are you able to get that working?
Yeah, I'm dealing with my sharing screen, but I'm changing my preference of the computer, so it takes a little while.
Cool.
Oh yeah, that it can be an issue depending. You may need to even close.
I have a comment while we wait for Shona. I was searching for this option to know where the face is on the XY position.
Yeah.
So there's not option for this, right? But maybe this is useful for someone. What I figured out is that you can take the X and Y position of the sprite. I mean, you can tell the sprite to follow your nose, and then you can take the position for the sprite. Just a comment while we are waiting for Shona. I realized that just now.
That's a really nice insight. And if you kind of work backwards from that, maybe you can get a glimpse into our process too, where from the other end of it, the technology underneath just gives X and Y coordinates for these things. And we felt that that was a little bit too low level in the sense of technical, just to provide that as blocks, and that using the go to nose block or things like that, which are super simple and get you to one set of things that you want to really fast, make it really more, we think of it as more expressive and more accessible, but then you don't have that low level access. And so we've gone back and forth on this. It's another thing that is part of the experimental nature. It's like, should we also have blocks that give you the X and Y coordinates of the face parts? We also try to keep the total number of blocks relatively small. So there's always compromises there. But yeah, you figured out a workaround.
Are you working on another experiment on the Scratch Lab? Is it confidential, or you can tell us?
Not really secret. We have like a lot of ideas of things that we've tinkered with over time, but there isn't a current next phase for Scratch Lab planned yet. We're hoping to do that.
But we did make there is another existing Scratch Lab, which we haven't mentioned.
Great point, Paul, yes.
Yeah, I'll put the link to that in the chat in case people want to play with it. And that one is responding to a lot of kids in the community wanting an easier way to play with texts and fonts in an animated way on Scratch. Okay, cool. I see Jonathan has started sharing.
Whoa!
Oh, amazing.
Can we see your code, please?
Yeah.
That's rad. Look at that.
Like, no.
I'm dealing with my mustache, but you know, it's kind of so I thought to make me a mustache, but I already have one. So
That
this is
just
great,
like
guys. Thank you.
Super stylish.
Oh, that's awesome.
Yeah, thank you for this. I think I'm going to enjoy this for a long time, also with my kids. And this is a very powerful feature. So thank you very much.
That's great. Yeah, thank you for sharing.
That's wild.
One thing I really like about that is having the eyes separate from, you could make a single sprite that was on your face, but it looks like you have separate sprites for the eyes and for the head. And it means that as you move, the eyes kind of, they jiggle a little bit separately. You could even play with that, like move them around randomly or rotate them.
Yeah, it turns out googly eyes are kind of a sweet spot for face sensing. There's a question from Justin about using face size. Could you fake depth mapping? Yeah, kind of. That's actually something I have not seen an example of yet, but you could make a game where you have to dodge things front and back, I suppose, by measuring the face size, and then that could tell you like where you are in the kind of plane pointing out of the screen, and then you could make sprites that go by and you have to dodge in front or behind them. It would be a fair amount of code, but definitely possible. That's a really cool idea. I had not thought of that.
Just got a few minutes left if people have impressions or stories from the last 20 minutes that they want to share. And if you find like feedback you want to give us later too, we welcome that now. There's also a give feedback button at the top of every Scratch Lab, so the two that already exist. It's a white button that says give feedback, and you can always put something in that form as well.
Cool. If you're totally stuck or confused or couldn't get it to work at all, we'd love to hear about that as well. That is okay. It helps us to know about that.
Just picking up on mentioning playing with your kids on it. Scratch is obviously designed for a kind of a certain age range. I think we talk about being like 8 to 15 or so, as being a kind of, that's like who it's core designed for. But this particular feature, I really like to play with it with my daughter. My daughter's 2, almost 3, and she loves to play kitty, which is usually means play with Scratch, but in particular because there's something about things being on your face and that being the way the computer sees you, as being like a really nearby concept for even much younger kids. And some of these other chat programs that let you do similar kind of face things are like a really common mode for talking to my younger cousins as well. There's something about it. I can't talk to them unless they've turned themselves into a puppy or a pizza.
That's another comment from Harvey. I teach my youth Scratch through the CASA Code initiative. Just wanted to share that we really enjoy using the tools, and these new developments are going to be great fun once we introduce youth to it. Yeah, awesome.
Oh, that's great. Thank you for sharing. Yeah, curious where they'll go with it.
Any thoughts on like detection zones, for example, if I wanted to block this side of the screen so that I've got a wide webcam, it'd be more useful for me than other people. But if I wanted to not be tracked while I was over here so that you could use it with your blocks of code only when you enter into this section.
That's interesting. It definitely seems like something that you could do with slightly more complex code, depending on exactly what you want it to do. You could use like an if statement with if the X position is greater than something, so forth.
I'll just post the one pager that we sent out earlier, just so people have it again. There's some more resources on like further reading if you just want to learn about like algorithmic bias, and if you have students, like ways you can bring that into the conversation with them. It also has like the link both to the blog post that Scratch published and the prototype that you all played with today. I'm just going to put that in the chat again. And I also just added to it the documentary that I mentioned called Coded Bias that just came out on Netflix yesterday. So it's all very current.
It's an awesome documentary, highly recommended. Very inspiring stuff.
Someone wrote, Ricky wrote, I used Scratch with our younger group. Just wanted to say, awesome job really finding characters and avatars that grasp the user's attention. Oh, awesome. Thank you for that feedback. And Hallelujah wrote, thank you for this unique opportunity. Thank you, Hallelujah. Yeah, thanks for playing around with it with us.
It's an excited puppy.
Oh yeah, I was like, I wonder if you can hear that. It's like a dog barking in the park.
It happens.
Cool. We'll linger around if there's any more questions or shares. Appreciate all of you being here.
Yeah, thanks so much for joining us today. Riley. Turning my eyes into basketballs. That's an awesome idea.
That's
I
a
love
right
it.
use case.
A unique way to see the world. Well, Jason did let us know that we had a hard stop at 2:30, trying to keep this whole event on schedule, which I certainly appreciate. So maybe we can just wrap it up here.